Alright, so we're on the back of the notes. We've drawn a 4x4 graph. We wrote skew lines, parallel lines, perpendicular lines, and we're deciding if they are on the same plane, intersecting, and if they have a special effect. So skew lines, they're not on the same plane, they're not intersecting, there is nothing special about them. Parallel lines, they are on the same plane, they never intersect, and in order to know that they're parallel, you would see these triangles. Perpendicular. Are they on the same plane? Yes. Do they intersect? Yes, and when they intersect, what do? They form a right angle, but they form at 90 degrees. All right, and in a picture, I would know if they were 90 degrees or perpendicular. Sorry, let's draw it like this. Let's draw it better, actually. How would I know that they form at 90? Yeah, I would have the right angle box. Perfect. We can flip back to the front. We're going to use this information. It says, think of each segment in the diagram as part of a line. The reason it says that, lines never end, so when we name it, we're going to name it with the arrows above. Which line, or lines, or planes, contain point B and appear to fit the description? So we've got this interesting looking, it's a trapezoid, prism. We're going to find the line skew to FG that goes through point B. So we want to make sure it's not on the same plane and does not intersect FG. There's only one answer, and it is BC. BC. Because that will never intersect. It's not on the same plane. Perfect. Next one, we want perpendicular to FG through point B. So we want it to intersect and form 90. So what line would that have to be? BG. Number 3, we want parallel to FG. So we want it to be on the same plane and not intersect. So what would that be? Yeah, AB or BA. The last says planes parallel to plane FGH, which is this back plane. We want it parallel. Before we do anything, some people still don't know how to name a plane. What do we write first? Plane. We're going to use 3 points. So we could say ABC. You could say DAB, BCD. Perfect. The bottom section of this page says name a pair of parallel lines. What in this picture am I looking for to find parallel lines? The triangles. So there's 2 pairs. We're going to name both, even though it says name a pair. We're going to do both because these are notes. So we've got this line has 1 triangle, and so does this one. So because they have 1 triangle, they're going to be parallel to each other. So let's name this top line. What do we want to name it? The XW, yeah. And then we would say is parallel to, so we would use the 2 straight lines. Is parallel to, we're going to name the bottom line, which is YZ. Good. How many points were on this top line? Let's talk about that for a second. There's 1. There's definitely X and there's definitely W. There's 1 more point. What is the point? N. So remember that when a bunch of lines are intersecting, they're not going to put a dot here, but N is a point. We're going to name the second set of points, or second set of parallel lines, my bad. So this line has 2 triangles, and this line also has 2 triangles. So they're parallel to each other. What can we name this first line? UV or VU. Again, with those arrows above. And then is parallel. What's the name of my second line? QR. All right. Number 6, name a pair of perpendicular lines. What am I looking for to know the 2 lines are perpendicular? Right angle. So, here's my right angle. It is sitting on 2 lines. It's sitting on this line And it's sitting on this line. Okay? So, let's name both of them. Which line do we want to name first?
ST.
Sure. This line is ST. What does the symbol look like for perpendicular? Upside down T. So we said ST, which is this line, so we need to name the second line, which we could say UV. All right, and then the last, it says, is WX parallel to QR? There's two answers to this. Are they parallel? No. Why aren't they parallel? There's two reasons. They intersect is the number one answer. And then what else? They don't have the little triangle. They don't have the same number of triangles. One of them has one triangle and the other line has two triangles. So they don't match up, and obviously they intersect. So it said no. And then last it says is ST perpendicular to NV. Perpendicular would mean they intersect and form 90. So while there isn't a right angle here, how many degrees is a straight angle? 180. How much does this take up? 90. So how much is left for this angle? 90. So are they perpendicular? Do they intersect and form 90? Yes. Yes, and the reason you'd use the definition. They intersect and form 90 degrees. So we are actually going to split this into 2 days. We do that very often. But before we do, we're going to talk about a word. It sounds like a weird word. It sounds like a complicated word. This section is called parallel lines and transversals. So when you hear the word transversal, it doesn't sound like something fun or easy. But a transversal is a line. So what you're going to write, what kind of line it is a line that intersects two or more coplanar lines at different points. It is a line that intersects two or more coplanar lines at different points. It is a line that intersects two or more coplanar lines at different points. It is a line that intersects two or more coplanar lines at different points. So really what you're going to see here are two lines and one line cutting through it. So when you see this line is the transversal. Or it could look like this, where there are a bunch of lines that are, side by side, and then one line cutting through them. This line is the transversal. Transversal is just a line. So, you're not going to highlight it. We're actually going to go to page 2. There are relationships formed by these two lines, and they're given special names. So on page 2, there are 6 boxes. 2 of them you have already learned, and we're going to review them. 1 of them you have not, or 2 of them you have not yet learned. Okay? So keep in mind that in the last section, we had something that looked like this, and if we were given one angle, we could find all of them, right? If this angle was 30 degrees, what other angle was 30 degrees? The one across from it, right? What would the angle right next to it be?
150.
150.
Oh, okay. I was like, what?
Because what should they add up to? 180, and these two should add up to 180, and these two should add up to 180. Whew. It's okay. But this, if you can do this, you can do this. Because all it is the same intersection just twice. Okay? So we'll talk about it. Before we do, we're going to review. I just want you to look at this. It could look like this too. And again, the transversal would be this line. It's the one line that cuts through 2 lines. All right, so we're going to talk about the first term. It's review. A linear pair, I think that's the top right box. The top right. Linear pairs. I want you to remember 2 things about them. That they are adjacent, so you're going to write that in. But the more important thing, they are adjacent, but more importantly, they are supplementary. Supplementary. They They're adjacent, but they are also supplementary. So they share a wall, and they form 180 degrees, adjacent and supplementary. I know your picture looks like this. We're not going to draw because that would be, we're not going to highlight here. It would be too many things, but we can talk about them. What is angle 1 a linear pair with? So angle 1 and angle 2 are a linear pair. What is 1 also a linear pair with? 3. So angle 1 and angle 3. What is 3 also a linear pair with? Angle 4. And then 4 is also a linear pair with angle 2. All right, and then in the second intersection down here, it's the same idea. What is 5 a linear pair with? Angle 6, 5 and 6. Again, we're not really highlighting because it'd just be a lot. 6 is also a linear pair with 8. 8 is also a linear pair with 7. And then last, 7 is also a linear pair with 5. So we didn't highlight, but we will highlight in the future. These are supplementary. We've already learned about them. I think I show you this. We're just going to fill in the blank. Angle 1 is linear with what other angle in this picture? 1 and 2. What else is it linear with? 1 and 4. 2 is linear with 3, and it's also linear with 1. 6 is linear with 5 and 7, and 7 is linear with 8 and 6. Okay, just something to talk about. I show you this so that you can see a separate example of a transversal. I know that on your paper they all look like this, but I just want to make sure you're seeing it both ways. Because here's the transversal on your paper, and then when I show you this screen, the transversal is this one. So one line that cuts through 2 lines. Then vertical angles. What I want you to remember is that they are across from each other. They're across, they share a vertex. But the most important thing is that they are congruent. They're across from each other. They share a vertex. They are congruent. So this is where you can, if you want to, take your highlighter and highlight some of these angles. 1 is vertical with 4. 2 is vertical with 3. 5 is vertical with 8. And then the last 6 is vertical with 7. Good. So now we're going to learn the new ones. Those were not new. Those were, we've learned them before. Sorry, I didn't highlight 6 and 7. So we're going to talk about the first one, which is corresponding. You should see a box for corresponding. I think it's middle left. Corresponding angles. I'm going to fix this, or not fix it. This isn't wrong, but make it a little simpler. There are 2 angles that occupy the same. We're going to say the same spot. The same spots. We'll make it plural. There are 2 angles that occupy the same spots. What is it? Yeah, perfect. So you're going to take your highlighter. This is where, if you have multiple highlighters, it's helpful. So here's what I mean by same spots, and Dorian definitely just got it. The top left is the number 1, right, of this top intersection. An intersection is where 2 things cross. So we've got the transversal and this line crossing. Angle 1 is in the top left. In our second intersection of the transversal and our other line, what angle is in the top left? 5. So they are corresponding to each other because they occupy the same spot. They both occupy top left. So with one color, you can do 1 and 5. Then we can do 2 and 6. Because 2 is in the top right, 6 is in the top right. 3 and 7, and then 4 and 8. Perfect. Corresponding angles. You up?
I just like the way it writes out like 1, 2, 3. I don't know why it is.
Me too. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Here's what you need to know about corresponding angles. So yes, they occupy the same spot, but also if two parallel lines, like in our picture, are cut by a transversal, then the corresponding angles are congruent. So I would make that a big deal on your picture, that corresponding angles are congruent, which means they're going to be the same measure. You what? You can just write congruent. So it should make sense, right? If they occupy the same spot, they should be the same measure because they are pretty much the same, just in a different location. So make sure you wrote congruent because it's very important. So again, I show you this picture where our transversal is just sideways instead of up and down. So let's talk about 1. What would 1 be corresponding with? 1 and 5, 2 and 6, 7 and 3, and then 8 and 4. Good. Our next one is called alternate interior angles. So a couple things. When you think of the word interior, you think of inside. That is where these will be located. If you see I have a couple angles missing. They are inside of the double lines. And as part of the definition I'll have you write down, is that two angles that are inside of the double lines and are on opposite sides of the transversal. So they're inside of the double lines. That's what makes them interior. They're on opposite sides of the transversal. That's what makes them alternating. So they're inside of the double lines and on opposite sides of the transversal. So the trick I teach my students is, because sometimes these pictures get a little more complicated, if you just connect the double lines, you can very clearly see what would be inside and what would be outside. So 1, 2, 7, and 8 are on the outside. We would call them exterior angles. So the ones that are missing here are going to be interior. So 3 is this one, right? It's on the left side of the transversal. The angle that will be alternating and interior will be 3 and, whatever this is, 6. 3 and 6. And 4 and 5. So with one color, you'll highlight 3 and 6. And the other color, you'll highlight 4 and 5. You just want to make sure you don't get this mixed up with something like this. 3 and 4 are not alternating interior. While, yes, they are both on the inside of the double lines, what relationship do 3 and 4 have? They're a linear pair. So these two are adjacent. They're not an alternate interior angles. Okay? The only alternate interior, they alternate across the transversal line. All right, here's what you know about their measurements. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Congruent. So they're going to be the same measure. Same measure. So in my picture, again, here's your transversal. And then there are your double lines. So what angle, we'll start with, what angle is on the inside of the double lines? 3. What is 3 going to be alternate interior with? 5. Good. And then 4 and 6. So if you have alternate interior, you're also going to have alternate exterior. It's going to be the same idea, except for these are going to be located outside of the double lines. So there are two angles that are outside of the double lines and on opposite sides of the transversal. So outside and on opposite sides of the transversal. So again, you can always connect the double lines so you can see what's on the inside, and then we can talk about which angles are exterior and alternating. This is 1, right? 1 is on the left side of the transversal, so my alternate exterior will be on the right side, so it'll be 1 and 8, which will pop up. 1 and 8, 2 and 7. 1 and 8, 2 and 7. So the last one is consecutive. Nope. It's going to show you this. Again, your transversal could be horizontal like this. So then what angle, just give me one angle that is on the exterior here.
1 and 8.
Yeah, 1 and 8 would be alternate exterior, and then 3 and 6 would be alternate exterior. Good. Now we move on to, nope, getting ahead of myself. If 2 parallel lines are cut by a transversal, then the pair of alternate exterior angles are congruent. So congruent. They are congruent. Now we're moving on with our lives. We are. This is the last one. It's called consecutive interior. So, consecutive interior, the only difference, they're obviously going to be located on the inside of the double lines, but they're going to be on the same side of the transversal. So there are 2 angles that are on the inside of the double lines and on the same sides of the transversal. So inside the double lines and on the same side of the transversal. So, inside the double lines and on the same side. So this is angle 3, which is on the left. What other angle is on the inside, but on the left side of the transversal? 5. 3 and 5. And 4 and 6. So these two, their measures are not congruent. What they are going to be is supplementary. If 2 parallel lines are cut by a transversal, then consecutive interior angles are supplementary, which means they add up to 180. Good. We'll do this one more time. What angle is on the inside of the double lines? Just name one. 3, which is on the top of the transversal, right? So what is consecutive interior with 3? 6. 3 and 6, 4 and 5. Good. So here's what you're going to do. And before we even get to that, if you notice, there are 6 boxes on your paper, and 2 of them look a little different than the others. We're not moving from this page. Not yet. Which 2 boxes look different or bolder? Linear pair and consecutive interior. What do you know about those 2? What do they have in common? They both add up to 180. So these are your notes, not mine, but I would make some way to show that they are the only 2 that are supplementary. So maybe re-highlight them, like the box around, something like that. So you can know that those are the only 2 that are supplementary. The rest of them are congruent. So linear pairs, which you've already learned about, and then consecutive interior are also supplementary. The other ones are all congruent. Now we go to our whiteboards. So what you're going to do is you're going to tell me if each pair of angles are vertical, linear, corresponding, alternate interior, alternate exterior, or consecutive interior. I can help you start just to make your life a smidge easier. When you're going through the list, which I would keep your notes open, because we are going to continue with this, what I would go through first is, are they both on the inside or both on the outside? These 2 on the screen. Are they both on the inside of the double lines or both on the outside of the double lines? This is a yes or no question. One's in, one's out. So, if they're not both on the inside, they can't be alternate interior. If they're not both on the inside, they also can't be consecutive interior because they're not on the inside. Are they both on the outside? They're not. So they can't be alternate exterior. So you're only left with 3 options. So always ask yourself, are they both on the inside, are they both on the outside, and go from there. So you want to tell me what relationship they have and if they are congruent or supplementary. You're correct. Aramis, I can see you, so if you want to show your answer to the screen, I can tell you if you're right or wrong. Good, good. Good, good, good. They're corresponding, which means they are congruent. Here's the next one. Correct. 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 You are correct. Except for I just need to know if they're congruent or supplementary, Aramis. Correct. They are alternate exterior. They're on the outside of the double lines. So does that make them congruent or supplementary? Congruent. Correct. Good. Correct. Are they both on the inside of the double lines? No. Are they both on the outside? No. So these are corresponding. They're both on the bottom right. So does that make them congruent or supplementary? Congruent. We have a new question. You have to tell me if they're congruent or supplementary.
Oh.
Are they both on the inside or both on the outside? They're both on the inside. Are they on opposite sides of the transversal or the same side? Same side, so that makes them consecutive interior and supplementary. Yep. Correct. 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 So they're both on the inside. Are they on the same side or opposite sides of the transversal? Opposite sides, so that makes them alternate exterior and congruent. So they're going to be congruent. We got one more? Good job, Aramis. Good. Alternate exterior and congruent. Good. We're going to go back to our notes for a minute and then come back to the boards. So you can flip to the next page. We're going to actually apply. It says the measures of 3 of the numbered angles are 120. Identify the angles and explain your reasoning. So we're identifying all of the angles that are congruent to 120. So what angle is also going to be 120? Well, you can start with 4. You're not wrong, but we're getting ahead of ourselves. You're not wrong. We just got to do one thing at a time. Angle 4 will be 120, and then it's going to explain our reasoning. So you explain the relationship that makes them the same measure. So what relationship did 120 have with the angle 4? They're vertical. So we're going to say vertical angles are congruent. You can do the shorthand, vertical, and then the angle symbol are congruent. That's the first one. The next one Noah said, and then everyone else echoed, it's true. Angle 5 will be 120. What relationship does angle 5 have with 120 degrees? They're corresponding. So 120 is in the top left, angle 5 is in the top left. So we know corresponding angles are congruent. What is the last one that will also be 120? Angle 8. What relationship does angle 8 have with 120? Their alternate exterior. So you can shorten it to alt-X. And they are congruent. I still want you to take your highlighter. I'm going to try to help you. Take one highlighter. We're going to highlight all of the angles that are 120 first. Then we're going to highlight with a second color. The remaining angles will all be the same measure, and you are already equipped to know what the measure is. How would you find the measure of angle 2 if you knew the measure of angle 120 degrees? Subtract. 180 minus 120 is 60. So it didn't ask us in this picture, but all of the ones we highlighted in our second color would also be 60. Okay, we're going to go back to the board and we're going to do something similar to what we were just doing. The only difference is we're going to identify each pair of angles as vertical, linear, corresponding. We're going to do the same thing, but instead of saying they will be congruent or supplementary, you're actually going to tell me the measure. So if they're going to be congruent, you need to tell me what the measure will be. If they're going to be supplementary, tell me what that measure will be. So start with this one, tell me the relationship, and then tell me the measure of the question mark. Correct. Very cool. Yes, ma'am. Good. Yes, ma'am. Good. They are alternate exterior, which means the measure will be 110. They'll be congruent. The next one. Tell me the relationship and then find the measure of the angle. Correct. 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 Not quite. The name of it was correct, but the measure was wrong. Correct. Correct. They are alternate interior, which means they're congruent. So 84. This next one. Correct. Correct. So you have to write the second word. But also the measure's wrong. Correct. Correct. Aramis, you are correct. 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 Well, the measure I think is wrong. Consecutive interior, what do we know about those measures? They add up to 180. So 180 minus 100 is 80. So these are consecutive interior, and the missing angle was 80. have to keep looking at it like it's going to change. Correct. Yes, ma'am. Yes, ma'am. Yes, sir. Good. They're alternate, maybe. Did you write interior or exterior? Okay. They're interior, good. And that means they're the same measure, so 111. Got a couple more? Good. Yep. Yes, ma'am. Yes, ma'am. Yes, ma'am. Correct. They're alternate exterior, which means they're the same measure, 47. Tell me the relationship and then the measure. Which one are we on? We've got one more after this. Correct. Correct. Good. 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 So they're not both on the inside or both on the outside. They are both, however, on the bottom left corner. So they're going to be corresponding and congruent. So 53 degrees. This is the last one for today. Identify each pair of angle and then find the measure. Good. 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 Not quite. Yes, ma'am. And then Aramis, not quite. That's better. You can erase your board and set it aside whenever you answer your last question. So they're both on the inside. They're both on the inside, and they're on opposite sides of the transversal. So they're alternate interior, which means they're congruent. And this is 113.